We're talking today on the back side of our 6-1 notes. Okay, and we're going to start out here with this rule. It's a rule in the book, and I want to explain it here just so that you don't get confused, because we're actually not going to use this rule, okay? I mean, not that we can just say, oh, we're not using it. We're doing a certain stipulation here. So what they're talking about here, they're saying it's tempting to do this. That situation, we saw that on the notes before, notes on the previous page, where we had the square root of -2 squared. They're saying it's very tempting to say that the square root cancels with the square and your answer is -2. Okay? We cannot do that when we're dealing with just numbers. You have to follow your order of operations. Okay? The square root symbol or the radical signs are like a grouping symbol. You have to do everything that's inside them first before you take the square root. So technically, what we need to do, if we have the square root of -2 squared, we have to evaluate this first. Then we can take the square root. Okay? That's what we're doing. So that's what they're trying to talk about here. They're saying, well, if this is an even index, then your square root is going to be the absolute value of that value inside. Okay? Doing that, it's true. It happens when you're dealing with numbers. And we can see that when we're dealing with numbers. But when you are working with variables, it gets very confusing as far as where do I put the absolute values and what does that mean and things like that. So we're going to simplify our work today, and we're going to assume every time we're dealing with variables, we're going to assume that the variables are positive. That's just what we're going to say. Our variables are positive. So if we have the square root of x squared as just our problem, they're giving us that, we're going to say that our answer is x. The book is going to want you to say the answer is the absolute value of x, just like it was up here. Now x is the -2, right? We didn't get -2, we got +2. So that's where that comes from. We're going to say that our variables are positive, so we're not going to have to worry about that absolute value business. Okay? But I wanted to address it because it's in the notes, and it's in your book, and I want to make sure that you understand that we're not doing that part. Okay? We're just going to assume our variables are positive and work from there. So, that being said, let's go ahead and take a look at example A. Let's just dive into an example. So in this example, what you need to remember is that we are able to go through, we've done this before, but never with nth roots, that if we have the nth root of A times B, that is the same thing as the nth root of A times the nth root of B. We've seen that rule before, we've used that rule before, but it was only with square roots, because that's all we talked about up to this point, right? We're square roots. So all that's telling us is that we're able to evaluate this square root separately. It's basically like cutting that in half and saying, okay, well, what's the square root of 16? 4. Okay, well now we want to take the square root of x to the -8th power. Don't lean on that, please. So we now have to take the square root of x to the 8th power. So what we want to do is we want to rewrite x to the 8th power as something to the 2nd power. We always want this exponent inside to match the index. X to the 4th power. This is why we spent time reminding ourselves of those exponent rules. If you have a power raised to a power, you multiply the exponents. So x to the 4th squared is x to the 8th. So now, what's the square root of x to the 4th squared? X to the 4th, exactly. Okay. Let's try an question. Yes?
So it's like...
Let's try the next one, B. We have all variables here, or all variables, A and B. So we want the cubic root of A to the 6th power, B to the 9th power. So what we need to do is break it down into something to the 3rd power times something to the 3rd power. So how do I rewrite A to the 6th?
A to the 2nd squared.
a squared to the third power. How do I rewrite b to the ninth? B cubed, or b to the third power, to the third power. Okay, because again, when you take an exponent to an exponent, you multiply those guys. So, evaluate this first one. What is the cubic root of a squared cubed?
A squared.
A squared. What is the cubic root of b cubed cubed? B cubed. All right, let's see here. Let's try one at the bottom here. So this is the second example A. The second example A. Just to make sure everybody understands what's going on, because some of these problems will be larger than just two things inside, okay? We are using that original rule saying that we can break up radicals. Okay, so for example, I am trying to take this as the square root of 81 times the square root of x to the fourth. Okay, that's what I'm working with this as. All right, and so then what is the square root of 81? 9. Okay, well the square root of x to the fourth, I have to rewrite that as the square root of something squared. X squared squared. Yeah, x squared squared gives me x to the fourth. So therefore, what's the square root of x to the fourth?
X squared.
X squared. Okay? All right, I want you guys to try example B on your own. Go! We have the cubic root of something to the third power times something to the third power, because we want this exponent to cancel with that exponent. Or I'm sorry, this index to cancel with that exponent. So a to the 12th power is a to the 4th power cubed, because 4 times 3 is 12. We take a power to a power, you multiply them. B to the 15th power is b to the 5th cubed. So then, if I take the cubic root of that first one, I'm just getting a to the 4th. If I take the cubic root of that second one, I'm simply getting b to the 5th. There's my answer.